Let's find the volume of the solid of revolution obtained by rotating the region bounded by parabola y equals x squared, line y equals x, as this region is rotated about the horizontal line y equals to 4. So here is our region. Here's part of the parabola that we need. This is a part of the line. There are 2 points of intersection here and here. The x-coordinate of this point is 1, and of course this is the origin, so it's 0. Next we draw the line of rotation, axis of rotation, which is line y equals 4, and then just make a sketch of this region as it is on the other side of the axis of rotation, that is 180 degrees of rotation. Here's what it looks like. Now pick any x between 0 and 1. Keep track of this vertical piece of the area. 180 degrees later, that's where it is. 360 degree rotation is going to yield a washer that looks something like that. The problem for us is to find the area of this washer as a function of x and then integrate for x between 0 and 1. So let's recall that when we do have a washer, it has this big circle and a small circle is cut out of it. Let's say the radius of the small circle is little r. The radius of the big circle is big R. We want to find this area between the two circles. Clearly that's pi big R squared minus pi little r squared, or pi times big R squared minus little r squared. So now the goal of this next part is to express the area of this washer as a function of x. Notice that the center of this washer is on the axis of rotation. Here is the center, this point on the line y equals to 4. The big radius would be from here to here. I'm drawing it now, the length of it, so we're going to call this big R, and the small radius would be, let's say, down to there. That's little r. How do we compute big R as a function of x? From the axis of rotation to the x-axis, the distance is 4. That clearly is too big. We have to subtract this part, and which is the y-coordinate of the point on the parabola corresponding to x. That y-coordinate is x squared. So the big radius is 4 minus x squared. The little radius, similarly, it's 4 minus the y-coordinate of the point on the line, and that of course is x. So big radius 4 minus x squared, small radius 4 minus x. And now the problem becomes of integration. The volume is pi times the integral from 0 to 1 big radius squared minus small radius squared. So let's simplify this. This is pi times the integral from 0 to 1, 16 minus 8 x squared plus x to the 4th minus 16 minus 8x plus x squared. And notice that 16's cancel. 16 minus 16 is canceled, and we're left with the integral pi times the integral from 0 to 1. Negative 8x squared minus x squared is negative 9x squared plus x to the 4th, and then minus a minus 8x would be plus 8x. This is a very easy integral. It's equal to pi times negative 3x to the 3rd plus 1/5 x to the 5th plus 4x squared evaluated from 0 to 1. Now as you can see, plugging in 0 will give us 0 because everything has an x in it. So it's just plugging in 1. This is pi times minus 3 plus 1/5 plus 4. 4 minus 3 is 1 plus 1/5 would be 6/5. So the answer is 6 pi divided by 5. For more